You know, usually when we talk about artificial intelligence, we have this very specific picture in our heads, right?
Oh, definitely, like a chat box.
Exactly, yeah. We picture it living on a screen. You type a prompt into a text box, or, maybe you ask your phone to generate some flashy image and the magic happens entirely within that digital rectangle.
Right.
But what happens when you drag that intelligence out of the data center and onto like a volatile offshore oil rig?
Yeah, or a high-pressure chemical plant.
Right. So today, for this deep dive, we are unpacking a giant stack of press releases and this massive white paper launch from May 2026.
Mm.
And it's all regarding EON AI Ventures and their new spatial AI platform, which they're calling Illuminated Intelligence.
Yeah, that's a cool name.
It is, right.
Mhm.
We are looking at how this company is proposing to take literally billions of dollars worth of unused 3D industrial scans and turn them into highly actionable, AI-driven operational tools for you.
What's fascinating here is that the AI industry has essentially spent the last decade pouring, you know, billions into building intelligence for screens.
Right, like generative text?
Exactly. Text, coding assistants, image creators. But EON is explicitly pointing their technology at the actual physical world.
Mm.
And not just any physical world, but environments where mistakes aren't just, a glitch on a screen.
Yeah, the stakes are way higher. So for this deep dive, you and I are stepping into the gritty, heavy-duty world of major industry. We're
Right.
talking oil and gas, chemical manufacturing, mining, power grids. The stakes literally could not be higher.
No, they really couldn't.
Okay, let's unpack this. To understand why this platform matters to you, we have to look at two massive compounding problems that these industries are just slamming into right now.
Yeah.
The first one is a massive stranded asset problem, and it's all regarding reality capture.
Right, because they've spent an absolute fortune on it.
Oh, totally.
Over the last, say, 10 years, global super major oil companies and, pharmaceutical manufacturers, they have sent technicians all over their producing assets.
So scanning everything.
Exactly, just to create incredibly detailed 3D digital maps. They use photogrammetry, which
It's
is,
the photo stitching, right?
yeah, essentially taking thousands of overlapping high-resolution photos and stitching them together to create a 3D space.
Right.
And they also use laser scans to build these massive point clouds, which are just millions of tiny data points that map the exact dimensions of a physical space.
Okay, so they have these perfect, hyper-detailed 3D replicas of their plants.
Mm-hmm.
But the sources highlight a real tragedy here. All of that beautiful, ridiculously expensive data currently just sits on servers as what the white paper calls inert geometry.
Inert geometry,
Yeah.
that is a perfect term for it.
It sounds so sad.
It does, because it's essentially just a massive, complex 3D picture. The computer looking at it, it doesn't know that a specific, cluster of pixels is a crucial pressure valve.
Right.
Or that another cluster is a highly flammable pipeline. It just registers a shape.
Just a blob of data.
Exactly. So it's a stranded capital expense. They paid millions for it, but they can't actually use it to operate the plant.
Man, it's like having a high-definition photograph of a locked door, but you still don't have the key.
That's a great way to put it.
And that brings us to the second much more urgent problem, which is the great crew change.
The brain drain.
Yes, we are watching decades of deeply ingrained, highly specialized operator expertise just retire and walk out the door.
Yeah.
You have these veteran workers who know exactly how a specific pump is supposed to sound.
Or, the quirk of a particular chemical mixer.
Right. And when they retire, that institutional knowledge just vanishes.
And when that knowledge vanishes, things break.
Big time.
The text points out that unplanned downtime in the oil and gas sector alone, just oil and gas costs, an estimated $38 million per offshore platform per year.
Wait, per platform?
Per year.
That is an insane amount of money.
It is. But the financial cost of a paused operation is, it's only one dimension. The founder of EON AI Ventures, Dan Lajerskar, he points out that every major incident the industry has lived through has a procedural and knowledge root cause.
Right.
He specifically references the Deepwater Horizon disaster,
Oh, wow.
which carried a $65 billion bill.
A $65 billion bill. I mean, and for you listening, it's easy to think of that as just a corporate loss.
Yeah, it's just numbers on a spreadsheet.
Exactly, but those costs ripple outward. When a massive refinery goes down unexpectedly or, a rig suffers a catastrophic failure, that hits global supply chains.
Oh, absolutely.
It hits the price of the gas you put in your car, the cost of plastics used in medical devices, everything.
Exactly. The stakes are completely global.
Hmm.
So you have a situation where critical safety and procedural knowledge is literally leaving the building every time a veteran worker retires.
Right.
And these facilities remain inherently dangerous.
So having a massive server full of unused 3D facility scans is it's like owning a highly detailed map to a treasure that you simply cannot read.
Yeah.
You know the environment is complex, you have a picture of it, but it doesn't tell a new worker what to actually do.
The map is there, but the instructions are missing.
Right.
And, well, EON had to invent a pipeline to fix this. And we should probably establish their pedigree here, because they aren't exactly, some Silicon Valley startup sketching ideas on a whiteboard.
No, they've been around.
Right. They have a 25-year history in immersive industrial training.
Wow, 25 years.
Yeah. Over 4,400 institutional customers across 80 countries.
That's huge.
And over 136 million platform downloads. So they have basically been the leaders in building the virtual training world for industry.
Okay, but now they're dragging that virtual world into the physical world.
Yes.
So how on earth do they make these giant 3D photos interactive? Because the white paper details how they solve this inner geometry problem, and the first thing they realized is that gathering the data wasn't the issue.
Right. The first step they define is simply scan.
Which is already done.
Exactly. Which the operators have already done. They take all that existing reality capture, the photogrammetry and point clouds, and just feed it into the EON system.
Okay.
But the second step is where the technology actually has to work for its keep. They call it decompose.
Okay, wait. I want to make sure I'm visualizing this correctly for the listener.
Sure.
Imagine you have a giant solid block of plastic that has been molded into the shape of a complex car engine.
Okay.
It looks exactly like an engine, but you can't turn the belts, you can't unscrew the spark plugs because it's just one solid piece of plastic.
Right. That's the inert geometry.
Exactly.
Right.
What I understand this decompose stage doing is taking that solid block and breaking it down into individual functional Lego bricks.
Oh, yeah.
Now, it's not just a picture of an engine. It's an engine made of distinct interactive parts.
That analogy perfectly illustrates the goal.
Thanks.
But technically speaking, the way they achieve those Lego bricks is through some incredibly heavy-lifting spatial AI.
I bet.
The AI runs real-time object segmentation against those massive point clouds. It uses computer vision, which has been trained on massive industrial CAD libraries.
CAD libraries, so like blueprints.
Basically digital blueprints of millions of industrial parts, yeah.
Wait, so the computer vision is looking at a billion tiny laser dots and just automatically figuring out what every pipe and valve does.
Yes, exactly.
Yeah.
It looks at the curvature, the dimensions, the placement within the inert geometry, and it recognizes, for example, oh, that is a 6-inch gate valve.
Oh.
It essentially cuts that specific valve out from the background and assigns a digital tag to it.
So it isolates it.
Right. It turns a cluster of pixels into a recognized, addressable piece of machinery.
I mean, that is a massive computational leap.
It really is.
Okay, so now we have our interactive Lego bricks. The computer actually understands the machinery. But how does that help the new worker who just started on the rig?
Well, once the 3D twin is decomposed into those interactive parts, EON moves to the simulate phase.
Simulate. Okay.
They run this new intelligent twin through their Genesis 3 simulation engine.
What is Genesis 3?
Genesis 3 is essentially a physics engine that makes the virtual world behave exactly like the real one.
Oh, like a video game engine?
Exactly like that. In this engine, workers can safely practice complex or, dangerous procedures in a completely virtual environment.
Right.
But they are interacting with a functionally accurate digital twin of the exact facility they're going to fly out to next week.
Okay, I mean, that sounds incredibly useful for training in a safe office, right?
Definitely.
But it's still virtual. I'm hung up on the deployment here. A chemical plant isn't a training office.
No, it's not.
You can't just hand a guy an Apple Vision Pro, send him out to a live gas leak, and hope the virtual training kicks in.
Yeah, and that is exactly where the fourth stage comes in, which they call Illuminate.
Illuminate.
EON takes that exact same training data from the virtual simulator and pushes it out into the actual physical field using their Field IQ layer.
Field IQ, what is that?
It's an augmented reality overlay.
Oh, okay.
They push this intelligence to the worker via hands-free smart glasses.
Got it.
So the worker is standing in front of the real physical machine on the rig. They look at the machine, and the glasses overlay the exact procedures right in their field of vision.
Like pointing to things.
Yeah, highlighting the real-world valves, guiding them step by step based on the logic of that decomposed digital twin.
Okay, and because they are following this step-by-step overlay, that means the system is tracking everything they do, right?
Exactly. Which brings us to the final stage, scale.
Scale.
Every time a worker completes a guided task using those glasses, the system generates continuous outcome-tagged data.
Oh, I see.
Say records what valve was turned, how long the procedure took, and, whether it was completed safely according to the established protocol.
Okay, so we've gone from scanning to breaking the scan down into Lego bricks, simulating the training, illuminating the real world with smart glasses, and scaling the data.
The white paper synthesizes this with a really great phrase. They call it one twin, two surfaces, one continuous data stream.
That's catchy.
Right. They use the exact same decomposed digital twin twice.
Huh?
First, as a surface to train the worker safely in a simulator, and second, as a surface to guide and verify that same worker on the live physical asset in the real world.
Okay, I have to push back here, though.
Sure.
This all sounds very, very elegant on paper, but we are talking about explosive oil rigs.
Yes.
We are talking about chemical plants with highly combustible atmospheres, strapping consumer electronics like a battery-powered smart glass headset to a worker's face in those environments sounds like an absolute disaster waiting to happen.
It does sound sketchy, yeah.
Right. One tiny spark from a lithium-ion battery in a chemical plant, and you don't just have downtime, you have a catastrophic explosion.
This raises an important question, and you're touching on the exact hurdle that has kept spatial AI out of heavy industry for so long.
Yeah, I'd imagine.
Safety isn't just a priority. It's the absolute non-negotiable baseline. You simply cannot bring standard consumer hardware into a hazardous area.
So what's their workaround?
EON addresses this with a very strict tiered hardware architecture that is co-authored directly with each operator's health, safety, and environment function, the HSE.
Well, co-authored sounds nice in a press release, but what does that actually mean for the hardware?
It means a strict three-zone architecture. In safe zones, like an administrative office or a dedicated onshore training facility.
Like the simulator.
Right. There, they can use consumer-class spatial computing glasses. But the moment a worker steps over the yellow line into a live process environment, the rules change entirely.
The danger zone.
Exactly. No consumer hardware ever crosses into the danger zone.
So what are they wearing then?
The system explicitly mandates certified, intrinsically safe wearables for live hazardous environments.
Okay.
The sources specifically name-drop the RealWear Navigator Z1.
Okay, intrinsically safe. Certifications are great on paper, but we're talking about invisible explosive gases just floating in the air. Has this actually been proven to be bomb-proof?
Oh, it goes far beyond just a piece of paper.
Really?
Yeah. The RealWear Navigator Z1 carries the gold standards of industrial safety, specifically ATEX Zone 1, IESEX, and CSA Class I Division 1.
Okay, that's a lot of acronyms.
It is. To give you an idea of what that actually means practically, ATEX Zone 1 certification means the device is engineered for an environment where explosive gases are likely to occur in normal operation.
Wait, so the gas is already there?
Exactly. It's expected to be there. And intrinsically safe means the device is physically engineered so that it cannot produce a spark.
Wow.
And it cannot reach a surface temperature high enough to ignite that specific gas atmosphere.
Even if it breaks?
Even if the device is dropped, even if the battery malfunctions and shorts out internally, the casing and the circuitry are designed to contain that failure, so it never interacts with the explosive air outside.
That is wild. So the software intelligence of this massive AI platform is running on hardware that is essentially bomb-proofed from the inside out.
Yes, it gets the AI out of the safe office and physically onto the hands of the worker, turning the wrench in the most dangerous part of the plant.
Okay, here's where it gets really interesting for me. If these bomb-proof glasses are tracking everything the worker does, every turn of a wrench, every inspection, isn't that creating a massive data set?
Oh, absolutely massive.
What are they doing with all that data? Because the white paper kind of hints that human workers are actually only the first phase of the master plan.
Yeah, this is where EON's strategy borrows heavily from a very proven playbook. If you look closely at that continuous data stream from the scale phase, you realize they are building the foundation for industrial autonomy.
You're talking about robots.
They are talking about robots, yeah.
Man, this reminds me exactly of the big tech autonomous playbook.
How so?
Well, if you look at how companies like Tesla or Waymo tackled self-driving cars, they didn't just lock a robot in a lab and try to program every possible driving scenario.
Right, that wouldn't work.
No, they deployed humans equipped with sensors at a massive scale. Tesla has millions of human drivers effectively mapping the roads and capturing all these weird edge cases every single day. You capture the infinite complexity of the real, messy world, and you use that massive data set to train the autonomous system.
It's the exact same logic, just applied to hazardous heavy industry.
That makes total sense.
And it's important to realize that the hardware for this robotic transition is already walking around the plants.
Wait, robots are already there?
Oh, yeah. The sources note that major operators like BP, Aker BP, and Woodside are already deploying quadruped inspection robots. You know, the robot dogs.
Right, the scary-looking robot dog.
Yes, those. They are already on producing oil and gas facilities.
Right, but right now those robot dogs are mostly just like walking around with cameras, right?
Pretty much.
Maybe sniffing for gas leaks or reading analog gauges. They don't really know how to actually operate the plant. They need a software brain for complex manipulation.
Exactly. The missing piece for industrial robots isn't the legs, it's the training data.
The brain.
Right. How does a robot know the complex sequence of safely shutting down a valve network during an emergency? Or how does it know how much torque to apply to a specific rusted bolt?
It learns it from the humans, that continuous data stream.
Yeah.
Every time a human worker puts on those certified real-wear glasses and follows the field IQ guidance to complete a task, they are generating structured, labeled, outcome-tagged data.
Yes. Because the platform uses those decomposed digital twins as the anchor, the data is perfectly structured.
Oh, because it's already mapped to the Lego bricks.
Exactly. The system knows exactly what physical component was interacted with, what the worker saw, how long it took, and what the successful outcome looked like.
That's incredible.
It feeds that directly back into the core intelligence. The human worker is doing their daily job, but simultaneously, they're creating the exact corpus of data needed to train the next generation of hazardous area autonomous robots.
So if I'm an executive at a chemical plant, I'm not just buying a fancy set of safety glasses. How is EON structuring the business side of this?
Well, EON AI Ventures offers standard flat licenses and tiered licenses.
Like a normal software subscription.
Right. But the commercial model that really stands out in the white paper is their outcome-based structure.
Interesting.
They specifically highlight value share pricing tied to measured avoided costs.
Wait, meaning EON ties their own compensation to how much money they save the operator?
Precisely.
That's bold.
It is. If EON's platform successfully guides a worker to fix a problem that prevents that $38 million unplanned downtime we talked about earlier,
Right?
EON actually shares in that captured value.
Yeah.
It aligns their incentives perfectly with the operator's actual outcomes. And the release notes that early deployments are already underway with a global super major oil and gas operator.
No kidding.
Yeah, with advanced discussions happening with multiple Tier 1 operators. Dan Lajerskar, the founder, makes a crucial point here.
What's that?
He says operators are building a defensible institutional knowledge asset. They are banking the data that the next decade of industrial autonomy will run on.
Let's bring this all together for you. We started by looking at a massive problem, right? Billions of dollars in stranded, inert 3D facility scans.
All that inert geometry.
Yeah, and a terrifying brain drain of retiring human expertise.
Yeah.
Then we unpacked how EON's platform takes those scans, uses computer vision to break them down into interactive Lego bricks, uses those bricks to train workers in simulation, and then pushes that intelligence out into the real world.
Right to the source.
Right. They guide those workers using heavily certified, explosion-proof smart glasses. And all of that human activity is secretly the engine generating perfectly structured training data for the autonomous robots that will eventually work alongside them.
It is a profound shift in how we view industrial work.
It really is.
And it leaves us with a truly fascinating, almost philosophical thought to consider.
Oh.
We are talking about human workers using spatial AI to map the extreme edges of human intuition in these highly hazardous environments.
Right.
By simply doing their daily tasks with these smart glasses, these veteran operators are actively downloading their irreplaceable expertise into the very robotic systems that are destined for these danger zones.
Oh, wow.
It makes you wonder, are we currently witnessing the final generation of human hazardous area workers, actively engaged in training their own robotic replacements?
Man, that is a wild thought to end on. You're giving them the map, but you're also teaching the machine how to read it forever. Thank you for joining us on this deep dive. Keep questioning the world around you, and we'll catch you next time.